Hey there, Scott Wilkinson here, the home theater geek. This week's guest is one of the world's preeminent speaker designers, Andrew Jones. Hey, Andrew, welcome to the show.
Hey Scott, hi everybody. It's fun to be here.
It's so nice to have you here. As we go, I'm going to be following the comments. So if you're watching on YouTube or Facebook and you post a comment, it will appear in my stream here, and I'll pass along some relevant questions as they come up. But in the meantime, let me do a little intro here. I know that most of you who are watching and listening probably know the name Andrew Jones, uh, but you probably know it from his work at Pioneer and ELAC, at which both companies he made some really stellar speakers at surprising prices, shall we say. But recently, you moved to another company, MoFi Electronics. Now, MoFi is short for Mobile Fidelity, and I thought Mobile Fidelity was a record label, but apparently not only, right?
Correct. I mean, that's how it started. But in recent years, they've added a number of uh, strings to the bow, let's say.
Very good.
um, One of which is selling hi-fi. Music Direct is one of the companies.
Hmm.
So that's catalog sales and internet sales,
Hmm.
obviously these days. There's also MoFi Distribution that bring in and distribute into the US lots of brands from overseas.
Hmm.
Wharfdale, for example,
Hmm.
Quad.
High end brands, in other words.
Well, not just, I mean, Wharfdale do very affordable speakers.
Yeah, it's true. True.
They do
Yeah.
quite a wide range.
Yeah.
So there's a mix, and they've been very successful with that. And more recently, they started manufacturing. So you've seen the MoFi turntables. And there's even a MoFi turntable that's co-branded with Fender that has a
Really?
plinth. So the plinth is actually made by Fender here in North Hollywood, and
You mean like
uh,
Fender guitars?
Fender guitars, yes, and it's finished in that starburst kind of
Oh,
color.
wow.
It
Wow,
looks
that's cool.
magnificent. So that was
Yeah,
a
wow.
limited run, but they've been doing well with that, and they're starting to do some electronics to go with that, and they bring in some cartridges. Um, I think Japanese manufactured.
Hmm.
And then they got the idea of, well, why don't we do speakers so that we can, you know, that old idea of source to sound. If they're
Hmm.
doing all the remastering and of the vinyl, and of course the recent announcement that they have a brand new facility for pressing. So there's a
Ah,
pressing
yes,
plant,
of course.
yeah, out in near Oxnard. So about an hour and a half away from here.
Hmm.
And I say here because um, although MoFi are headquartered in Chicago and their um, turntable and electronics manufacturing is done in Ann Arbor, Michigan, I'm here in Beverly Hills of all places.
90210.
90211. It's close
Oh,
enough.
you're one digit off. Okay, all right. So you get to have your own facility there in Beverly Hills.
Yes. So this is a design lab,
Hmm.
but it will also be a space where uh, the whole company can have access to it, particularly my listening space and facilities, because um, we'd speak to record executives all the time and
Sure.
all sorts of people about doing all the repressing. So a lot of those people are here in Beverly Hills and LA in general. So
Yeah, yeah.
it's a
So,
useful place to have.
right, for you to be working on your design and also for other people to come in and hear the records and your designs once they become product. And we're going to talk a little bit about that. Not too much because it's still a little under wraps, but
Yeah.
it's well known that you have now moved over to MoFi, not Wi-Fi. um, so what attracted you to MoFi?
It was a really interesting opportunity. Again, this source to sound, it was particularly relevant to me when I was with TAD because TAD started as a pro brand. the beryllium compression drivers
Mm-hmm.
targeted for studio use, and then adding the mid bass drivers and the bass drivers. So they became really successful with that, and many of the major recording studios throughout the world are fitted out with either TAD built speakers or TAD drive units incorporated into Ausberger designs or whatever.
Mm-hmm.
And so through that, and also Pioneer, when Air Studios was set up, when it originally burnt down, or typhoons, I think, in the islands that it was built on,
Mm-hmm.
when they rebuilt it in England, Pioneer was a 50% partner in that. So we had access to Air Studios. And in fact, we used their facilities for them to, as we were developing some of the products, for them to comment on it, and then we'd pass that information back and redesign the product and whatever.
Mm-hmm.
So I enjoyed getting closer to the music production side,
Mm-hmm.
because how am I supposed to know what my speakers should sound like? The argument goes, if I don't know what they were trying to make the sound like.
Mm-hmm.
And
This is very much like I always say in video. You want a display, a consumer display, to reproduce what the content creators were seeing when they created the content.
yeah, I think that's actually an easier ideal to approach with video than is with audio.
I would agree.
So, in fact, I had this conversation. A family friend of mine is a film director and producer,
Mm-hmm.
and he's just finishing up a movie that he's been making. And we were talking about TVs and reproducing it. And he's got some OLED TVs in his home. And when he had them calibrated, they were so close to what the monitors at the film studios were calibrated to. He said almost no difference. And in fact, a lot of the studios now are using those self-same OLED monitors to replace some of the standard precision monitors. So I think that's easier to do than sound. Of course, I'd say that because I want to justify my role. Otherwise, my job's done. Just put a microphone down.
Put up your speakers and you're done. Yeah.
Yeah.
Give us your thoughts on why it's more difficult with sound.
I think one of the reasons is speakers. Any other electronics, you've sort of got one input and one output, and you can relate one to the other. With a speaker, you've got one input and infinite number of outputs, because you're radiating sound into space, and it will both sound and measure different at every single angle you choose to measure. And then that sound is folded back to you by virtue of it being in a room. If you listen to a pair of speakers in an anechoic chamber, so that you only hear the direct sound from a very narrow cone of projection of the sound, obviously, sounds awful. I mean, I've done it often enough, but no, you don't really want to do that. It's an awful environment in which to listen. So you are going to listen in an acoustic space. And again, if you try and listen to a stereo system in an acoustic space that's too dead, it just doesn't, it kind of robs the life out of the sound. So because we're used to constantly hearing sound all the way around us, and when we hear real live events, we do so, even if we hear a not live event in the sense that we go to a rock concert, we're not listening to the instruments.
No,
we're listening to the sound system.
Right, the speakers of the PA system.
Right, and whatever mixing and EQ was done to separate out each instrument in the mix so that you can hear it all.
Right.
So, but you're still surrounded by the ambience of the space that you're in. So we need to listen in some kind of ambience. The question is, what should that ambience be like, and how does the speaker interact with that?
there are so many different rooms that have so many different acoustical characteristics that every time you put a speaker in a different room, it's going to sound different.
Yes, it does. The question then is how different. Obviously, speakers with different directional characteristics are going to interact with any particular room in a different way.
Mm-hmm.
So now we've got to think about the directional characteristics of the speaker, the absorption, reflection, diffusion characteristics of the room and the size of it and how far away you sit.
Mm-hmm.
And knowing at the same time that we're listening in an acoustic that is on top of whatever the recorded acoustic was.
Ah, good
right?
point. Yeah.
But that recorded acoustic is not an accurate representation of the acoustic we listened in, because it's now trying to capture sounds from all the way around the listener
Mm-hmm.
and fold it into two channels at the front.
Mm-hmm.
That's not accurate. So it's a interpretation depending on how you choose to record that acoustic space versus maybe close miking the instruments. Everything's an artifact. Just capturing the sound on two microphones through two speakers is an artifact.
Right. Microphones don't work the same way as our ears.
Or brains.
Or
I mean,
brains. Good point. Good point.
Even the ears are pressure transducers.
Yeah.
But they're buried down a cavity, which has got acoustic resonances.
Yep.
And then we've got the pinner, which modify it. So that gives us the head-related transfer functions. It gives us the ability to separate spatial events due to the way they interact at particular angles with the ear.
Right.
And that, headphones. What should the pressure response of the diaphragm of a headphone be when it's clamped to your ears as opposed to speakers out here? So there's all sorts of things that matter when you're trying to design either headphones, but particularly speakers, because they do have the room to interact with.
Yeah.
So the more I know about what people are trying to create originally with the music, at one time I used to use this closest approach to the original artistic intent rather than the original artistic event, which we cannot do. It is impossible.
Right.
So intent, well, what did they really want you to be able to hear? But even that, it's too pat of, I've Cookie Marenko. She hates people saying that. Kind of had to apologize. Sorry, Cookie. But at least getting to know the record producers and engineers and everything, you get more of an idea of what goes into producing a record.
Right.
So in a way, you could say that's a bad idea, because I know that there is no reality at all in most of the recordings. So why the hell am I trying to preserve any kind of accuracy?
Right.
And that gets us into, so what is accuracy in terms of designing a speaker?
Indeed.
I've already said it's different at every angle. So which angles matter most? And I know Floyd's done a lot of work with this.
Tool, you're talking
Floyd
about.
Tool, and published many books.
Yeah.
And I've known him a long time. He's the guy who invited me over to the States in the first place. Yeah. And a lot of that work, we'd started it at KEF when I'd built 30 concentric drivers before the UniQ ever got to market. I was doing a research project, 5-inch UniQ drivers in a spherical enclosure, and there were 30 of them arrayed fully around you in a huge anechoic chamber at the Technical University in Copenhagen.
Wow.
And we'd got a 32-channel discrete DSP engine that we'd built. And we could have a program that simulated in any given room where all the reflections were coming from, how much delay and which direction. From that, we could program each of those, and if lots of them seemed to come in roughly from the same direction, we could bunch them together into one of the speakers, because we can't have an infinite number of speakers around us.
Right.
But we'd bunch them into the appropriate directions. So then we could sit in an anechoic chamber and simulate any speaker directivity we wanted. We could simulate any room we wanted. You know, you sit in there, and I said, you listen to a pair of speakers in that anechoic chamber, and you go, this sucks.
Yeah.
then you flick the switch, and oh, now I'm in a room, but I'm in an anechoic chamber.
That's
it was uncanny.
incredible.
And then we could turn off the floor or turn off the ceiling. silly, gross things like that we could do, just so that we could start to explore characteristics of reflections from different directions and whatever.
Oh man!
So we built all
this. If any other company has done anything like that, simulating a room in an anechoic chamber.
So since then, there's been lots of attempts, but this was one of the first, and it was an enormous undertaking. But Floyd, then with the National Research Council chamber in Canada, he started doing simplified versions of that and starting to do a lot more psychoacoustic testing, and so carried on and set up all the work that Floyd is well known for.
Sure.
But it's still, it comes down to, I think, we can sort of decide, can we get close to accurately reproducing the original acoustic event? The answer is no. If there wasn't an original acoustic event, it was manufactured in a studio, can we reproduce that? Well, if you build a studio in your home with the same acoustic characteristics and use the same monitors, like we were saying with the TV monitors,
right?
Then technically you could, but you'd have to change the room and the monitors for every recording you were listening to, because everybody uses different monitors, different rooms, and they use different monitors for different purposes during the making of one recording.
Yes.
Yeah, we've all seen the Overtones.
Right, the tiny little speakers on the console.
Or the Yamaha NS10s.
Right.
And then you've either got Genelex, or you've got ProAC, or you've got ATC, or you've got a myriad of other
Tannoys or
near field, midfield, far field monitors in those studios.
Right.
So,
and you're listening to your mix on all of them to see what it sounds like from the far field, near field, midfield, how it sounds on tiny little speakers that you hope might simulate something like a boom box or a small home system.
Exactly. I went round to Steve Vai's studio. He's up in the valley, not far from my house. So, the guitarist. So
San Fernando Valley, for those of you who might not know that term. Those of us from LA know it well, but
where Valley Girls come from.
Exactly, where Valley Girls.
Most people will know that. Most nerds will know that.
Right.
So, I was taking my ELAC powered three-way, concentric speakers, and for him to listen to. So I got there. I work with his engineer. We get them all set up to listen to. Steve comes in, get introduced, and he pulls out his iPhone and he says, "So these are powered?" Yeah. So can I hook them? Can I broadcast from my iPhone so I can listen to some of the tracks I got on my iPhone? I'm going, no. I've just been working for the last half hour plugging it into your desk and making sure that that's available to kind of get the best impression.
Right.
Okay. So he queues up and starts listening that way. But it was interesting that his first idea was, I've got music on my iPhone. Can I listen from that?
Right.
So
which is so common today.
Which is so common. So it's absolutely necessary when you're doing a mix to know that the instruments in that mix will be represented sufficiently well under all sorts of different circumstances. So there isn't necessarily one single vision of what that sound, that intent is. But I need to follow up with him, because I said, I had this discussion with him, and he's telling me on all the different systems he listens to while he's mixing some of his stuff. I said, I'm always talking about this at shows, and how you don't really get to hear what the artist intended. I said, could we? I said, how about you take one of your mixers and on my speakers, you do a mix just on those speakers for how you want that to sound if it's reproduced through those speakers. Then I can take that special mix and play it through my speakers at hi-fi shows and go, you know how you never get to know what it should sound like? Well, you will now.
Here it is. This is what it should sound, because the guy who made it made this mix.
Made this mix for these speakers.
Yeah.
That would be an interesting ear opener
No
for
kidding.
people. So I need to follow up on that.
I please let me know when you do, because I want to hear that too.
So
go ahead.
Yeah, so that's where I am now. You know, regardless of the technology I choose, in my mind, it's what am I trying to make that technology do? There are measurements. There are guidelines for measurements. And you know, you read through all the Floyd's work, which Klippel was also a disciple of Floyd. He and I worked at Harman concurrently at one point. And he's now gone on to establish new standards for measuring speakers.
Who is
are
this
a bit
now?
more Klippel, Wolfgang Klippel. So if you see all these like Audio Science Review and Erin Hardiston, you know, Erin's Audio Corner, they've all got Klippel measuring system, and it's variable between $40,000 and $100,000 to set up a full system. So not many people do that, but it's a very comprehensive, but it sort of derives what the far field response would be if you could measure it that readily, but it does it within a room and has ways of eliminating the room and measuring near field and projecting what the far field sound would be. So it's very complex processing in order to derive the measurements, but nonetheless it gives you measurements at different angles and groups them all, and the standards take some of the sidewall angle measurements and the ones that would go up to the ceiling and off the floor, combine them to say this is the room response, which isn't really. It's a partial energy response that sort of represents maybe what it would do in a room, but it doesn't actually represent the room because every room has got different absorption and diffusion characteristics.
Right.
So just because you get a curve doesn't mean that that has to be the exact curve that every type of speaker needs to have. So it still comes down to listening. And, you know, I've said this a lot of times before. On top of that, I've never designed a perfect speaker. No surprise.
There is no such thing. Right?
So I don't admit failure under those circumstances. But especially
but no, because there's no such thing. It can't be done.
Right. So our job as speaker designers, in particular, because that's my forte, is that I'm trying to assess amongst all the imperfections which ones matter. Well, how do I do that? Unless I continually bring in pools of people and say, what's your preferences? Because we can't bring in people and determine what they think is the closest approach to the original sound, because we've already dismissed that as being a possibility. So now it comes down to preference. You don't know what those recordings are supposed to sound like. So what would you like it to sound like in your head? And that's governed by your past life history of what you've listened to and what stage of life. So I have an idea of over a varied set of recordings, what I think they should sound like. And then if I can't exactly achieve that because I'm limited by price point or technology or whatever, then I've got to make that compromise and go, you know what, I can't fix. If I fix this one, I'm probably going to make this other part worse. So which way do I go? And I make those judgments all the time. And I like to think that I have some self-consistency, because we would all wish that upon ourselves.
Indeed.
Yeah, I know what I'm doing. Well, trust me. But that's all I've got to go on. I make as many measurements as possible. And one of my missions through life, I've always been fascinated with measuring. So I've always tried to develop better and more accurate and consistent measurements. And it's not easy with speakers.
No, not at all.
I love thinking about that. And so I take care when I'm making measurements. And I never, in a design process, ever give the job of measuring a speaker to somebody else. Because I want to see, as it's coming in, what's happening and make sure, nothing's been missed and whatever.
Right.
So I will sit there for the several hours or whatever it takes to get the full set of measurements, but I will do that myself.
Right. And some of that you can do in your new studio. Talking about MoFi now, getting into the present, but some of it you can't. And you told me an interesting story before we went on the air about where you have to go to do certain measurements that I'd love to hear.
Yes. So this new facility, as
where you're sitting right now.
I'm sitting right now, listening room kind of behind me. So I've got a 20 by 30 listening room with 10.5 foot ceiling. So it's a nice space. And it's sounding remarkably good with my initial treatment. And I'm going through a full refit right now with new acoustic materials, of acoustic treatments and visual features and stuff. So it'll be a very nice, comfortable space to listen in. And I'm trying to make it so that it's not a bare room with some square panels stuck on each wall, because homes don't look like that.
Yes, exactly.
Right? So I want it to feel more like a English library kind of idea.
All right.
So, but I've got that space. I have the front office. I have behind that a measuring space, which is a relatively small room, but gives me good accuracy down to a certain mid-low frequency, and then combination of near-field techniques with diffraction calculations and all these different techniques and measuring impedance and predicting the response from that. There's all sorts of things you can do to cross-check all of these dissected ways of measuring that are accurate in certain ranges and not in others. And then you got to stitch them together to get the right answer. And I've spent years with having the availability of some of the best anechoic chambers I've ever been in to cross-check all of this against. But it's still not that you can stick a microphone in a room, put a speaker in a room, put a microphone in front, press one button, get a sweep and say, this is the sum total of the response of this speaker. It's not that straightforward. But the bigger the space you've got, the better it is to be able to try and get that
close to
simplicity of approach of measuring. And it just so happens that MoFi Distribution, their distribution warehouse is in Vegas, which is an okay drive for me. It's
I've always liked it.
Yeah, I like doing it. And so it's 30-foot ceilings, and I can get a 40 by 40 by 30 foot space to do these measurements. And it really does make things easy. It's not that I want to move to Vegas. No. When I joined MoFi, I said, I'm not moving to Chicago. sorry, anyone listening from Chicago. So it's a useful space to add to my measuring capabilities when I want to do certain more accurate, more simplified measurements.
You'll truck your speakers out to Vegas and do it there.
Yeah. But so MoFi has this history of remastering and pressing records, so being close to the music, and I loved that idea. I loved the freedom I was going to have with MoFi for doing speakers. If you think, I've always been with a speaker company. Now I'm with a company that's going to do speakers.
But that's not their primary focus.
But it's not. I mean, from a point of view of, if we say it's not their primary focus, it sounds as though they're not serious. Right?
Right. Okay. Good. Fair enough.
It's a clear focus of one of their objectives of bringing music to the people and letting them hear their vision of what they're trying to do when they seek out these recordings, remaster them for repressing, and now with the high quality pressing plant they've got, take that to the next level and down the chain. And so my goal is to design speakers that interest me, interest them, form part of that philosophy. And it doesn't mean I'm changing my philosophy, because I think we're united in what we're trying to achieve. But it's still, I have the freedom, I'm employed to do what I do. Otherwise, why choose me?
Right. Well, you've got a seriously good track record too.
Well, thank you.
So that obviously played a part in their decision to hire you to do this.
Yes, and so I'm loving that freedom to do this kind of stuff. And also, whenever you change companies, you after the initial shock of what am I going to do? Then you start having ideas, and then you start firming up those ideas and seeing how they fit in with what everyone else thinks would be good or sellable or whatever. And so we went through quite a time working on those kind of concepts and then honing in on the essence of what those ideas were. And ended up with something that we're all jointly know that, this is what we should be doing. This makes sense.
Excellent.
So it's very exciting when you get to that point. And it's not some people going, okay, I didn't get my idea, so I'm not signing on to this.
Right. Well, I'm glad that it sounds like it's a very cooperative and collaborative effort, and that's wonderful. Yes.
So I've been doing this for a year and a half now, and
soon we will have a MoFi speaker, which we can't talk about quite yet.
Nope.
But we'll have you on the show again when we can, when they're announced, because I'm sure the listeners will be very interested to know more about it. And I am too. So hopefully you'll come back at the time when the speakers are announced, and we'll talk about that. In the meantime, I would like to talk a little bit more about your philosophy of speaker design. For example, you have long been a proponent of coincident drivers.
Yes.
The KEF Uniq you mentioned earlier. You've done that also at ELAC. I don't know if you did it at Pioneer.
Oh, certainly did it at Pioneer.
Okay. Tell us what the advantage of coincident drivers is generally.
So if you remember, I said the speaker is one input and infinite number of outputs.
Yeah.
Basically, it's radiating into space in all directions.
Yep.
So what we'd like to do is have control of how it's radiating in all the different directions. And we could say there are two ideals. One is omnidirectional. So
of which there are some examples of speakers that are omnidirectional.
Purported to be. I did start by saying one ideal, right?
All right.
Now, there's always a difference between the maths and the physics and the engineering, right?
Yeah, all right.
I always joke that a physicist is a failed mathematician and an engineer is a failed physicist, and I've worked my way down to engineer.
Okay.
So so you're trying to construct a speaker that radiates uniformly in all directions at all frequencies. So the ideal point source, expanding sphere.
Right.
Not actually practically possible, so you approximate to it, either in just the horizontal direction or you glob things onto the surface and have them pointing
Or
in
you
every
limit the
direction.
frequency. You don't do it at all frequencies,
Or
but
you
you
don't
do
do
it
it
at
at all frequencies.
certain
And
frequencies.
so, although that's a physical ideal radiator of one sort,
Mm-hmm.
put it in a room, it's now the maximum excitation of the room that you can get.
Mm-hmm.
So,
Mm-hmm.
is that such a good idea?
Mm.
You have to think differently about the room acoustics if you're considering that type of speaker
Mm-hmm.
as opposed to a controlled directivity speaker.
Right.
And there are some good examples, and MBL.
MBL is what one thing I was thinking about.
That is a remarkable speaker, and even sometimes I think even more remarkable for the fact that when he thought of that technology to create that speaker, you think that's a crazy idea. And he's developed it to such a high degree of precision that it's a really, really good speaker.
Mm.
And they think, well, if he'd have chosen a more conventional approach, how would that have turned out?
Mm-hmm.
But nonetheless, it's an amazing technology and end results.
Yes.
I've always gone for more of the controlled directivity path.
Mm-hmm.
Obviously, to control directivity, the only non-secret is it's got to be big compared to the wavelength of the sound. Otherwise, you can't control directivity.
Mm-hmm.
So what that then says is, well, it's not going to have the same controlled directivity at all frequencies. It's going to be omnidirectional in the bass, and it's going to be semi-directional in the mid and high frequencies.
Mm-hmm.
But you at least attempt above a certain point to get a pretty uniform characteristic, or at least say over a certain angular range, there's almost no change at all frequencies, and then it can kind of fall off a bit more non-uniformly once we get outside of that window.
Mm-hmm.
Now, unfortunately, as soon as you split drivers into a woofer and a tweeter,
Mm-hmm.
they have totally different directivity responses.
Mm.
So they can never have a fully uniform off-axis response in all directions, particularly in the vertical direction.
Mm-hmm.
So you're now going to do the best that you can to stitch them together to give the best control achievable. Concentric drivers always fascinated me because they don't have this physical separation. So you can engineer a much more consistent directivity control in all directions.
Mm-hmm.
And it might not be as wide as a tweeter on top of the cabinet, like B&W, for instance,
Mm-hmm.
but it can certainly be very well controlled. And KEF in the last 30 years since I left, I've been gone nearly 30 years.
Oh, man.
Have done remarkable strides in their designs of concentric drive units.
Mm-hmm.
They've got fantastic team working there. They can do all sorts of FEM and boundary element analysis and lots of simulations. And they've really advanced the art of controlling directivity in those drivers.
Mm-hmm.
So, I love that because, I grew up at KEF. KEF was my speaker university.
Mm-hmm.
And to see them continue and do what they're doing now, it's fantastic. So, that's where, starting to work on UniQ, I was in the research group at that point when UniQ was being developed.
Mm-hmm.
It captured my imagination. So I've been fascinated with it ever since and done my own ways of understanding it and developing different drivers with it and solving some of the issues that the concentric driver does have that some people object to.
Just for example?
So there's always that old adage, oh, it sounds like a cone, right? Or a horn. Well, horns don't have to sound like that. And we know with the work of Bill Geddes and people like that of how to design waveguides to work much, much better these days. And the cone is the waveguide for the tweeter.
Yeah,
so
exactly.
Knowing some of the maths of that definitely helps. The other objection is, well, the tweeters bounded by a surface that is moving. That must cause problems. It must cause Doppler distortion. Well, we were aware of those arguments when we first started UniQ. And so we started measuring the Doppler distortion, because the way Doppler adds sidebands, as you move a source moving towards you versus moving away, the sound goes up in tone, then goes down in pitch. So what you do is modulate. If you've got a low frequency moving the cone and a high frequency superimposed, they'll produce sidebands around, say a 300 hertz tone and a 1K tone. You'll get tones at 700 hertz and 1.3, and 400 hertz and 1.7, and so on.
Difference and addition.
Some and difference.
Some and difference, yes.
Which is the same as intermodulation distortion. However, there's a fundamental difference: the phase of the harmonics. So on a simple spectral representation, they look to be the same. But if you plot phase, they are different. And if you study hearing, they have different effects. So the Doppler is very difficult to hear compared to intermodulation distortion. And so we did some of these tests, and then we conjectured, well, lots of people like full range electrostatic diaphragms. Perfect example of all the bass moving the diaphragm while the high frequency is on there as well.
Right, on the same diaphragm.
On the same diaphragm. Has anyone taken the full range electrostatic and go, oh, the Doppler distortion on that is awful? I challenge you to find anyone who says that.
Yeah.
So it kind of put my mind at rest to a degree. Now, of course, you have to make sure you keep other forms of objectionable distortion low when you're designing any drive unit, in fact.
Sure.
But, that's one of the issues we face. And it's also made easier if you do it as a three-way system. Once you cross over, like, a 5 or 6 inch concentric driver at a few hundred hertz, 200-300 hertz, it moves so little that you really don't measure those levels of modulation distortions. So I was always careful in the past to make sure I did that. And, so having left KEF and moved to, while I was at Infinity, that was my first job here in the States. Floyd invited me to
Floyd
join.
at Harman, yeah.
Yeah. That was not concentric driver technology. But then as soon as I joined Pioneer, one of the first systems I started work on was a new kind of concentric driver. And I think you got an image, keep going back in time, more towards the front.
More towards the front of that deck.
Yeah.
Chris. Not the very front. Okay, one more from that.
One more from that.
One more from that. There we go.
No.
Oh, no, that's not it yet either. Sorry. Those of you who are watching.
The one that looks like an eyeball.
The one that kind of looks. Oh, okay. Oh, yeah, that's another one. There you go.
That one. So that was a concentric driver where that whole black iris looking thing around the tweeter, that was a flexing diaphragm, because I said, I don't want any disruption of the sound wave as it spreads out from the tweeter. I want a continually smooth surface. And all drive units have to have some way of moving. The coil's in the middle, the edge is fixed. So you've got to let a typical cone move back and forth. So you have a surround, either a half roll surround or a corrugated accordion style edge.
Right.
And that disrupts the sound wave. So I said, just like in a headphone driver looks a bit like that it's got this flexing cone dome shape. And so I thought, could I make that work on a larger scale as a mid-range unit? And that's what that driver became. And we applied for a patent on that.
That was what was the name of that speaker?
That was the TZF700, or I think Phoenix, we called it at the time.
Okay, which at Pioneer at the time was a pretty high-end speaker.
Yes, it was. And also in that tall enclosure for the mid bass, we had a 12-inch downfiring woofer that was powered, but it was actually even before that at Infinity we had the Prelude speaker that had an inbuilt 12-inch subwoofer, self-powered but run at speaker level, and so you just plugged your speaker cable in as you normally would, and you didn't know there was a powered subwoofer there because it was already blended itself. It tapped off from the high level speaker signal, reduced it to go to the amplifier and through all the active crossover. So it now matched with the passive crossovers the rest of the speaker system. So that Infinity Prelude, it was a 96 dB sensitivity speaker, yet it went down to 30 hertz in a compact shape.
Wow.
Because it had assistance specifically on that bass driver, but it was all fully integrated, so you didn't have to have a subwoofer with all these phase controls and frequency controls and amplitude controls and go, how do I match this to my satellite speaker? You know, it's a funny thing that it's the speaker engineer's job to integrate all the drive units seamlessly. And yet when it comes to subwoofers, we go, I can't be bothered, you have a go. Right? Literally, you have a go. Mr. Customer, it's down to you.
Well, but that brings up an important issue that I wanted to ask you about, which is the difference between integrating a subwoofer into the main speakers versus having a separate subwoofer. Yes, that gives the customer more to do, but aren't there arguments against having the bass frequencies come from the same location within a room as the mids and highs?
So obviously, what we say with subwoofers is that below a certain frequency, they're non-localizable.
Right.
So certainly to a first approximation, you can place them anywhere in the room. And
where you place them in the room affects how they energize the room. How they, I mean, I've heard so many people say, you know, well, you've put a subwoofer quarter or half the way. Floyd Toole did this, quarter or half the way along a wall to.
Oh, are we back?
Yeah. Sorry.
I got spinning wheels. So if we can separate them physically, then we can place multiple subwoofers around the room. Not just, certainly one is a bad idea, two is a bit better, the more the merrier.
Yeah.
And if we can adjust the phase and amplitude at any frequency to each of those particular subwoofers, we can now not only improve the frequency response at the listening position, we can minimize the variation over the listening space.
Right.
And so EQ becomes less of a crapshoot.
Right.
And it's not that, I'm making it better there, but I'm making it worse for
over
someone
there.
sat over there. You make it better everywhere.
Yeah.
So, I mean, you can argue that, well, they're all different phases and different directions. That must have an effect. Well, if you do it right, it's remarkably good. And, you can say, is it phase coherent? Or, how important is true phase response from a speaker? Especially given that if I can really improve the sound in that room by controlling the excitation of the room modes, that gives a much bigger benefit than some loss of conjectured phase coherency, let's say. But most people are not going to put subwoofers all the way around the room. Most receivers are not configured to be able to separately adjust more than maybe two subwoofers with different signals to them. Obviously, there are some systems out there that can cope with that, but in general, they can't.
Right.
In general, stereo enthusiasts do not have separate subwoofers, but they like bass.
Right.
Most stereo amplifiers do not have a subwoofer output. They do not have any ability to high pass filter the main speakers.
Yep.
So even if you can, hook together the left and right speaker to sum up in a subwoofer and add it to a stereo system, since you're not filtering off the low bass from the main speakers, you are not able to play any louder because the same signal as ever is still going into your satellite speaker. You got more bass extension, but you haven't got more output level capability, unless the only limit you had was that it wasn't the speakers overloading, but then that really would be the limit. So yeah, it doesn't work. So in a stereo system, you then have to say most amplifiers not configured for you to readily add a subwoofer.
So have it in your main speakers. Have
it in your main speakers, but instead of leaving the controls up to you, I just engine it as an invisible part of the speaker. And it worked very well. And at least 2 subwoofers is better than 1.
So. Yeah. Well, we're going to go through some of your speakers of note in your long and distinguished career. Before we do, I got a question from Jared Redding, who says, is there much new technology in audio development? And I'm going to take that to mean speaker development in this particular discussion. Or is it refining the same ideals that we've had for a long time?
I think most of the advances in speaker drive units and cabinet has been material science. Which is interesting because I'm not using advanced materials in these new speakers. I mean, having done beryllium, there's not much that is significantly better than beryllium. So
for tweeters particularly.
Right. I mean, your 2 choices are beryllium and diamond as if the objective of an sort of almost infinitely stiff but light diaphragm. There are other materials that are coming along that are combinational materials that are pretty stiff and good internal damping and mode control, but they're not. It's a different kind of ideal that you're going for. But most times when you look, certainly at the measured performance of a lot of these speakers, if I didn't know what the material was, I'd be hard pushed to say which it was, because you look at titanium has got exactly the same stiffness to weight ratio as aluminum. Magnesium is only fractionally better as a stiffness to weight ratio. So, and then you look at some of these composites. So same sort of stories. Now, there might be more subtle things that you hear compared to some simple, straightforward measurements, just frequency response, for example. But still, materials technology is where we've been at for a long time in saying, oh, this is the new best
to improve
material.
The overall performance.
Right. Of significance more recently, I think, is the work being done on reducing magnetic or force distortion, magnetic distortion in drive units. The intermodulation products you get through the magnetic fields being modulated by the signal. And
that actually drive the voice coil and drive
the voice coil, yes.
And drive the diaphragm to actually vibrate, which is what you need to hear sound.
Right. And I've been doing work on that. One of the leading obvious company, Purify, with their drivers. If you that one with that curious surround that looks like a mountain range around the periphery of the drive unit, they've been minimizing all these distortion components due to the drive mechanism and due to the surround. Because what people don't realize mostly is the surround is there to contain the air in the cabinet to allow it to leak out, whilst allowing the cone to move.
Yeah,
but it is also a radiating element. It's clamped at the outside edge, driven from the inside edge, and as it moves, as the cone moves up and down, it changes shape, and its effective radiating area changes. Now, this has largely been ignored. It's not that it's not been understood before, but it's largely been ignored. But it's been known about, I mean, for example, motional feedback in subwoofers. I've known about this kind of thing for decades because I used to work in active noise control, and my brothers worked for decades in active noise control in headsets. And the surround, when you apply motional feedback around a drive unit to supposedly linearize the drive unit, most times you put an accelerometer on the cone and you say, well, cone acceleration is proportional to sound pressure level. If I can linearize the cone acceleration, then I've perfected the drive unit. No, you haven't. The distortion reduction claims are actually not possible because it's ignoring what the surround does. Controlling cone acceleration does not control the change in shape and radiating area of the surround, and especially in big subwoofers where you need a big surround to get enough movement. That surround plays a significant part in adding to the distortion of the drive unit. So motional feedback is extremely limited, and it's much easier to design a low distortion primary driver to get better results than to try and put motional feedback around a regular driver. So I've never been a big fan of motional feedback for that reason.
Okay, good.
But now people are doing stuff about it. And I say Purify, a great example of studying all those different aspects of what is left to understand and fix in a drive unit.
Right. Good question, Jared. Thank you. Okay, in the last few minutes, I'd love to sort of go through a little history of some of the notable speakers that you've designed. And here we have some graphics, some photos we can show, starting with the first one from Kef, the Model 107. This is probably one of your early designs.
So the 107 was done before I became chief engineer, but the 107-2, which was the successor to it, was the first one as chief engineer that I got to work on, the first reference series. Yeah, I first worked on some low-cost speakers. In fact, their entry-level speaker was the first one I did when I became chief engineer. So I just ended up 30 years later back where I started.
In entry-level speakers.
And made a name for myself from it. Indeed. So that was the first reference series. And then we did various others subsequent to that, including more coupled cavity speakers. And that was a very interesting time at Kef. I could take more than this hour just to go through the fascinating stuff we were up to in those days.
Oh man. Well, we'll have you back and we'll have a deeper discussion about that. Absolutely.
Yeah. And so then Floyd Toole brought me across the pond to work for Infinity. So
and that's the next
that
picture.
Was the Infinity Prelude, incorporating
which we were talking about earlier with the subwoofer in the bass.
Yeah. And interestingly, those mid-bass drivers, they're all paper cone.
Oh, really?
Infinity
with material.
They said, you can't use paper cone. Infinity uses the latest cone materials. I go, not in this case, they're not going to. That was engineered to be 96 dB sensitivity and a flat impedance curve. So it was very easy to drive and yet still went down to 30 hertz.
30 hertz.
So that was a cool design. And that was a extruded aluminum cabinet. So then we move on to
the next picture.
One of the first Pioneer speakers I did. They were $200 a pair at the time.
Oh man!
So still entry level, and what that was molded polypropylene cones, but they were set on that rounded triangular baffle, and that baffle was floating from the cabinet to isolate the mechanical vibrations of the driver from entering into the cabinet to cause cabinet vibration. Because the major excitation of cabinet resonances is not from the sound energy inside the cabinet, it's the mechanical energy pushing back on the magnet that goes through the chassis and into the cabinet. So if you can isolate that, you can reduce cabinet vibration noticeably, especially with cheap cabinets.
And the next one is actually a speaker that's just those baffles, huh?
Well, no, this is actually, that's, if you saw a 3D view of it, that's like a, the cross section is a flat oval shape. So it looks almost the same on the back, except it doesn't have drive units. Now that was a direct diffuse field loudspeaker in the days of Dolby Pro Logic, when you needed diffuse field. But then when we started getting into Dolby Digital, we didn't know whether we wanted direct or diffuse field. So what I did, that speaker had a mounting bracket, and it clicked on it to mount on the wall, and it faced out as a direct radiator. But you could unplug it, turn it around, and click it back on, and the drivers faced the wall, and they had directive bumps on that mounting plate to direct the sound across the wall.
Wow.
So now you listened in the shadow zone of the drivers, where there was no direct sound, but all the sound that escaped was diffuse field. And you just chose to do that once you got home. You could listen to it either way round and go, okay, I think I prefer diffuse field. But then when you get a Dolby Digital system, you just click it the other way around.
Wow, that's brilliant.
I thought so.
Well, I agree. That's really cool. The next one is a full picture of the infinities we were talking about before.
Yes. Yeah. So you can see the round base was the downfiring 12-inch woofer.
These are Pioneers,
these
right?
These are the Pioneer.
Yeah. Sorry.
Yeah. Yes.
And then we saw a close up of the mid-range.
I called it IRIS, ISO Radiant Imaging System.
You had to come up with some acronym that was I related. I get it.
Exactly. And that's the industrial design was done by Alan Boothroyd.
Ah, excellent. Oh, yeah.
Because I'd worked with him at KEF. He was the consultant to KEF for industrial design. So I thought, who better when I started at Pioneer?
Beautiful. Beautiful. And then we moved to TAD. And here you didn't have any price constraints, really, did you?
Correct. Originally, I thought I was going to. Then when we did research about what the reputation was of TAD was, and we visited Capitol Records, we visited the record plant and Bouton Studios and all these places, they all said, well, TAD drivers are the best. So, okay, well, if we're going to do something under the TAD brand, it has to be the best, it has to be a flagship. So I got to work on my first ever real flagship. And that was the model one.
The model one, which we just saw.
Yeah, and if you click down, you'll see that the next one shows some of the construction details. That was the cabinet. It was 52 layers of 3/4-inch plywood, each layer machined out and stacked. So the bracing was, go back to that.
Go back one, there you go.
So the bracing was integral to the sidewalls. It wasn't glued in. And
those are single pieces of wood.
Single pieces of wood, then stacked up and then finished. And then, so the next slide is the head assembly. This was the concentric driver in the middle of that head assembly. And that was a casting of 50% aluminum powder loaded epoxy. And it was sat on spikes on top of the base cabinet to partially control vibration transmission.
Isolated.
And then the drive unit, the drive unit itself was fully isolated from that top cabinet. So we had a very stiff, strong cabinet for the low frequencies, but that crossed over about 300 hertz to that separate head assembly.
Right.
And
so
then that was then superseded by the reference one that became a three-way system. So same concentric driver, twin 10-inch base drivers.
Right. And then finally, what we
and those are now in the current version sell for $150,000 a pair.
$150,000. Holy smokes.
Yeah.
Okay. Well, cost no object. You build what you build the very best you can, and you don't worry about the price. So fine. And then after that, we actually came up with a pair of quote unquote bookshelf speakers. We should probably more say stand mounted, right? The CR1.
Yes.
And let's take a look at the CR1.
The CR1, the compact reference. So it's the 8-inch mid bass plus the concentric driver. And that's my personal favorite out of all of them. It was a really nice speaker.
And so from cost no object, then you ended up back at Pioneer building what would become, I think, iconic value-oriented speakers. That's the next slide we have here.
Well, I was always at Pioneer. TAD was a
TAD is
Pioneer group
yes,
company.
you're right. You're right. Yeah.
And so I was doing double duty.
Yeah.
But yes, we had this request from Best Buy to design some speakers that were affordable, and so that was my mission. Price objective was about $90 a pair, and that's what I came up with for the bookshelves, and it was fantastic. What can you do at $90 a pair retail price?
Yeah.
And I set to work on it and was astonished at what I could incorporate. Yes, there's compromises, but it's still a real speaker with a real 7-element crossover network and a soft dome tweeter and a proper woofer with a decent sized magnet, curved sided cabinet, all this stuff for 89, initially 89, then it I think went up to 99 fairly quickly.
But still.
And then the Mark II version, where we did some more improvements, came out at $129 a pair.
Now those would not have concentric drivers, I think.
No, couldn't afford to put
concentric
drivers in those.
Right.
But it was hugely successful. We
sold. Man, people just really loved that stuff, as I did. I mean, I listened to them at trade shows and in review systems, and I just went, "How did you do that for $100 a pair?"
Yeah.
Remarkable.
Different challenge, but just as challenging and enjoyable. And at least I see people, a few more people buying those than could afford to buy the TADs.
Indeed,
put it that way.
Indeed. Yes, indeed. So then after Pioneer, you went to ELAC. And again, I think you made history there with the debut, which is the next slide, I think. Was that the first one you did there?
Yes. So although that's the Mark II version, that particular slide that I gave you. But the idea was, having had such success with those Pioneer speakers, there was still an even bigger demand now that, well, yes, I love the idea of a $100 speaker, and I bought them for the garage, for the bedroom, forever. But can you do something a bit more expensive that's even better performance? And so we looked at the next price point upwards. Instead of $129 a pair, we looked at around the $230 a pair and said, well, what can we do with that? And that became Debut. And so once again, it cemented that idea of caring about entry level and caring about the sound quality that you can get, so that we can attract people actually to enjoy the hobby at low cost.
Yeah. Well, and a great job on that, man. That was once again a tour de force that really rocked the audio world. And then finally, we have one of the later ELAC speakers that you did called the Adante.
Yes, and I'd done various speakers with ELAC that were concentric driver speakers,
which this is.
And this was the top of the range of what I was doing at that time, and that used a novel base loading technique, which you can kind of see partially of what's going on.
I was fascinated by this, that the driver itself is not what you see when you look at the front of the speaker.
Right. The driver is basically the rear half of the box is a vented box loudspeaker. And then the front cavity that the passive radiator is in is a box that the internal driver and the vents radiate into to drive the passive radiator to couple to the outside air. And it's a bandpass speaker combination, and it has certain advantages, one of which is the passive radiator, due to its mass and the compliance of the air, forms a low pass filter, so it filters off a lot of the distortion components that might be generated by the bass drive unit, and also simplifies the crossover function somewhat, because you've got an acoustic filter after the electrical filter. So another interesting concept that I wanted to explore, and probably sometime in the future we'll continue to refine.
Well, the future, the past was fantastic and really notable. the future looks bright for you. Will you come back and tell us about what you're doing with MoFi in a more specific product-oriented way when you actually have a product you can hold up to the camera and show us? Will you do that?
Yeah, I absolutely will. I'd love to.
Excellent, excellent, wonderful. Well, thank you so much for being here. It's been a fascinating discussion, and I'm so glad to have all your insight on speaker design, and I know our listeners are as well. So once again, thank you to Andrew Jones, Chief Speaker Designer now at MoFi Electronics, with some really interesting stuff to come. Thanks again.
All right. Thanks, guys.
So thanks a lot for watching and listening, and we will see you next time on AVS Forum Tech Talk with me, Scott Wilkinson. Until then, geek out.